What are we doing today? We are starting chapter 10. This is, and it's conveniently lecture day 10. And I don't want to use this pin yet. It's nice and clear. I want the other pin to go dead first. Chapter 10 is on solving quadratics, quadratic equations. And those are the ones that in standard form come like that. I don't know why when I looked up your last name, it didn't pop up the Canvas email, but when I looked your first name up in Outmail, Outlook, or whatever, it popped up all of them. It's fucking weird. All right. So 10.1 is on doing this with factoring and extracting roots. .2 is on completing the square. Factoring part. We've talked about the zero product rule before. If A times B equals 0, then A equals 0 or B equals 0. One of those must hold true. Maybe both, depending on what it is. So example, z squared minus 4z equals 0. We've covered factoring a lot already, so this is just adding the equal part. A lot of students are so used to factoring, they forget the equal part. You want to keep that equal 0 there, because this can get complicated. This one, not so much. What factor is here?
Z.
Just a z, right? What am I left with?
Z minus 4.
Z minus 4. So I can take this and say z equals 0 or z minus 4 equals 0. This is doing this part. Because this is like my A times B equals 0 right here. And we now got linear equations, we solve them. The left one's already solved, so we get 0 equals z equals 0 or z equals 4. That was just to illustrate it. But I don't think Lauren's having enough fun yet.
You said yeah.
I did. You don't look like you're having fun,
I'm concentrating.
which means you're not having fun. I can't think of very many things that if I have to, I'm really concentrating, I would describe it as fun. Satisfying, yes.
I'm making sure I'm writing down the right numbers. And letters, that's all.
You're doing a good job. I'm not criticizing you in any way, shape, or form. Keep doing what you're doing. I just want you to have more fun. Let's do our next example. 2y squared minus 12y equals negative 10. So I'm going to add 10 over. Now, this would probably be easier if I divided by 2. Just because they're all even, but I'm not going to. But I'll make a note of it. Should be easier if we divide by 2, but I won't. For the practice. Because we're not learning in here how to solve one problem. We're learning how to solve problems. Like it should work on everything. So what we do is we want to factor it. This is A, this is B, A equals 2, B equals -12, C equals 10. We want to factor that. We've done factoring before. A times C has got to be 20. And B has to be -12. So it's got to multiply to 20 and add to -12. If it multiplies to 20, they're either both positive or both negative. If it adds a negative number, they both got to be negative. So I'll just start with -1 and -20, and that adds to -21. That doesn't work. -2 and -10 multiply to 20. And that adds up to -12 right away. So I'm gonna split my -12y gets split based on these. -2y minus 10y. We split it up. And then we group. I put those together and these together. Looks like I can factor out a 2y here, leaving y -1. And if I want, it looks like I can factor out of a 10. If I leave it as a positive 10, I'm gonna have a negative y plus 1. So I want to factor out a negative. That'll make this a y -1. And the idea is that these repeat. So that we can factor again. We get that. So now we set each one of these equal to 0. And we solve, we get y equals. Add 1 to both sides, we get y equals 1. We'll add 10 and divide by 2. And we get y equals 5. So y equals 1 or 5. And why is math the best subject ever? Because when you're doing it on a test, you can check it and know that you're right before you walk out the door.
I got something interesting, which is that I factored it without doing the chart, and I just turned it into 2y minus 2 and y minus 5, and I still got 1 and 5. So would I lose points for that or no?
You do what?
So I factored it as instead of y minus 1 and 2y minus 10, I did 2y minus 2 and y minus 5.
No, that's gonna get you the same thing.
Yeah, so I was gonna say, but I'm like, but it is kind of, it's the same thing, but I'm like, would that be like inappropriate on a test?
No, because notice. What if I had changed the order here? That's an excellent question. What if I had said -10y minus 2y plus 10? Now when I group it, I got 2y times y minus 5. And here, I got a -2. And that gives me a y -5. And so I got y -5 times 2y -2, and lo and behold, I got what Davis got. That's deep, right? It's fucking whack. The other thing, like, that's the same thing as seeing that this is divisible by 2, factoring out a 2, this is really 2 times y -5. And moving the 2 over here. If we had divided by 2 in the beginning, we would have just had y -1 and y -5, and it would have been a lot easier. But not every time is every number evenly divisible. So like, it's better to learn the process that always worked rather than the fucking shortcut method that doesn't work very often. Right? If you can avoid the table and figure out the factors, best way to go. That comes with practice and experience. I very rarely need a table, but unless the numbers are really big, I can do all of it quickly in my head and figure out what works, but I practice a lot. All right, you guys ready for a harder one? Lauren may not have said yes, but Megan said yes. She said, yes, please.
May I have another?
Oh, what's going on here? All right. So we kind of want to get everything together. If I distribute, I've got that. And then I'm going to subtract shit over. Since I have an x squared, I want everything on one side. It needs to multiply to -30 and add to -13. If you jump to the gun and race to it too quick and say 10 and 3, you're wrong. Because one of them has to be negative and one of them has to be positive. And the bigger number has to be negative. So if I do -2 and 15, or -15 and 2, I'll get -13. And here I could have sped it up a little bit. As long as A equals 1, these are what get dropped in parentheses. But A doesn't always equal 1, so I don't think it hurts to go over the long form with you each time.
But if you wanted to get A to equal 1, that's where you divide by 1.
That's when we're doing completed squares. We didn't let, the last problem we did A not equal to 1 and we worked through it. Actually, I'm going to show the sub steps here. So we went from here to here and here to here. Which technically means we can go backwards. If you have, like if we had x minus x1 times x minus x2 equals 0, we would say x minus x1 equals 0 or x minus x2 equals 0. And we would add x1 to both sides here. Add x2 to both sides here. And we get x equals x1 or x equals x2. If you start with the solutions and you need the equation, you can go backwards. So let's find the equation. I would subtract x1 from both sides. And I get x minus x1 equals 0, or subtract x2, and I get x minus x2 equals 0. And now that they both equal 0 and we have an or, we can put them together as one equation. That's working with x1 or x2. Let's do this with some numbers. Let's say you have solutions of 4 and -3. I'm going to say x equals 4 or x equals -3. And work backwards. Finally, we'll put them together. Well, not finally, there's one more step. If we want the equation in standard form, we gotta multiply it out. And if you solve this, you're gonna see you get 4 and -3. Like if you did it by grouping, you would see this is 3x and -4x. We factor. We got x plus 3, we want x plus 3 here. X and -4. Notice these are the same steps, just going in different directions. It's the same steps in reverse order. But we had a little bit, I could have shortcutted here. And not done this, I could have just jumped to that.
You could have just jumped to that only because A equals 1, right?
Yeah. But it's like if you work backwards, we got the same lines here. I got the same lines here. I got x minus 4 and x plus 3 equals 0. And then I got my solutions. They're literally the same steps, just going in the other order. You're like basically you're undoing everything you did to solve. Give you a minute to finish writing that down, and we'll try another fun one. Because Sarah's not having fun now. She's twiddling her pencil because she's bored. Yeah, you got caught. Can't look bored in here. David will have more fun. All right. Anyone need a lumber? If so, say something or raise your hand. All right. What about if we have solutions of 2 1/4 and -1/3? It might have been a while since you worked with mixed numbers. This is the same thing as 2 + 1/4. And if we get a common denominator, we multiply this by 4/4. We've got x equals 8/4 plus 1/4 equals 9/4. So that's what that's where we'll start this part. That's some good old mixed number review. If it's been a while. Okay, so generally, none of these things ever have fractions in them. When we're factoring, right? We get fractions at the end. So if we were going the other way, we would have, like on this one, we would have divided by 4 in the last step. So we're gonna undo we're gonna say fuck fractions. This all boils down to fuck fractions. That's a good rule of thumb to live by. So I'll multiply this one by 4. And I will multiply this one by 3. And then I get 4x equals 9, or 3x equals -1. And we'll subtract 9 from both sides, and I'll get 4x minus 9 equals 0. Here I'll add 1 to both sides. I get 3x plus 1 equals 0. And now we can put them together. Seems complicated, right? But when you stop and think about it, what have we done? All we did was do some multiplying and some adding and subtracting. You just like got to remember the steps. And other than that, the math part's pretty easy. Like the math steps are pretty easy. Remembering the process. And obviously we wouldn't be done here. We'd multiply this out. Not forget fractions, Keith. He said forget fractions. At least go with something like fudge fractions or something like that.
The old one now is even EFF. Fraction.
F fractions. Yeah, that's that's the spelling of the letter F.
Yeah.
EFF. All you're really doing is just shortening to the first letter. All right, let's take a look at extracting. Well, hold on, people are still writing this. We're going to do extracting roots next. Okay. If x squared equals a, then x equals plus or minus square root of a. That's just some rules we had. This stems from, if we have like x squared equals, I'm gonna say like a1 squared. And we take the square root of both sides. X equals the absolute value of a1 there. And absolute value is our plus or minus. So like the connection between these two is just square root of a is a1. How's that help us? We'll make it easy to start with. Now we have a method for dealing with this, don't we? Without doing extraction. This is a difference of squares, or we could even do factoring. This is the same thing as x squared plus 0x minus 1 equals 0. So you could do your what you know of factoring here as well. But we're going to do the extracting method. We'll add 1 to both sides. And then when we take the square root, we get plus or minus the square root of 1, which don't ever leave it like that. I will make fun of you. It's just 1. I think Calc 3 students leave shit like that. Square root of 1 or square root of 0, or leave some shit like 2 divided by 1 on a test. You fucking shit me, you're in calculus. Finish. Don't leave it as 2 divided by 1. You know that's 2.
Also 2 divided by 1.
It is. But 2 divided by 1 is not simplified. Get rid of fractions when you can. And what this really means is x equals 1 or x equals -1. Let's not forget what plus or minus means. So if we work backwards here, we would see what we got. This was also difference of squares was doable here. We could have done difference of squares, we could have done factoring. We're doing complete or extract the roots just because we know it, the answer, and we can show you that it works. Well, let's kick it up a notch. X squared plus 27 equals 0. Not a big notch, but there's some nuances here. What should I do here? I'm going to go with extracting roots, which is really the only ones you know how to do.
Get the x squared by itself.
So subtract 27. Now if I take the square root of both sides, I get x equals plus or minus the square root of -27. Which is not our final answer. Because we want it in simplified form. And there's a couple of things that need to be simplified here. What can I do to make this a little simpler?
What's the, of the square?
It is 9 times 3. So 27 is 9 times 3. So square root of -3 times 9. I could pull out a 3, that would be, so plus or minus 3 root -3. If I pulled out the 9, it only comes out as 3 on the outside. This is a square root. Still not done.
Well, then,
Pull out the negative. Remember, square root of -1 is I. So final form is plus or minus. We tend to put the best spot to put the I is right there.
It's always gonna be plus or minus, even if there's an I.
Yep, because the plus or minus came from taking the square root of something. Which means, this is fun. Can I get back to x squared plus 27 with those answers? That's fun, right? This is fun. Are we having fun yet? I could subtract 3i root 3. I do the same thing over here. Oop, I need v equals 0. Yeah. Bask in the glory. This is like hearing angels sing. It's like a spiritual transcendent moment. Like the whole world has come together. Wow. So, if you're good at factoring, you could have just factored x squared plus 27 to this. It's a factored form, right? It's got a radical in there and it's got I in there, so most people aren't going to jump to doing that. With enough practice, you could do it, but like even then, it's still easier just to complete the square or extract the roots. You multiply it out, you got minus 3i root 3x plus 3i root 3x. And then minus 3i root 3 squared equals 0. There's a 0 there, I'll put it on the left. So that turns into 3 squared, I squared, and square root of 3 squared. What? What? No way. No way, that couldn't have been that easy. That wasn't too hard. That's like, this is like, put it on your fridge, right?
yeah, if you get it right on the test.
Ah, okay. All right. What about? All of this shit on red was just showing the whole starting with the solution, working backwards. It had nothing to do with extracting the roots. Finding the solution was the other part, which was arguably a lot shorter. It was putting it back together with the answer shows that it could be a lot. He's gonna hang it up in his bedroom, he said. That's a good idea. Put it where you can see it as you go to sleep. Wait, no, I'm even, it's gonna sound funny. But even especially coming from a math person, don't do that. Don't especially don't do complicated math homework an hour before bed. Give yourself some downtime. Even if you've got a lot of homework, you're taking like way too many fucking units, you got a job, kids to raise, whatever's going on. Fucking doing math homework right before bed leads to you having nightmares of like giant fucking numbers hurtling through the sky trying to kill you. It's not pleasant, I will tell you. From experience, it is not pleasant trying to have the number 1 stomp you to death. And you're running from it. It's not fucking pleasant. Don't, yeah. I've had some fucking, yeah. With what happens when you study math too much late into the night and do that right before going to bed, that's what's in your brain before you go to sleep. It's happened to me. All right, what do I do here? We want to extract roots, but like, I don't have a perfect square on the left. So we need to get a perfect square first. Which means that's a square, that's what the one we want. Let's subtract 25 from both sides. Now what? And what do I get if I square root?
Yeah, x minus 4 equals, I don't exactly.
So we got the plus or minus. And if you're not sure, just write the negative 25 for now. Whenever it's a negative, we can always write the negative part. We can do this as plus or minus square root of -1 times square root of 25. And square root of -1 is always I. So if I do that, I've got x minus 4 equals plus or minus, what's the square root of 25? That's 5, so I've got I times 5, which is 5i. We're almost done. Add 4 to both sides. X equals 4 plus or minus 5i. And as a reminder, that is very much 4 plus 5i or x equals 4 minus 5i. There's 2 answers. So we could work backwards on that one. What? I think I'm going to do it. I think it'll make you better students. You're going to have some shit like this when we get to polynomial equations and factoring them later on, getting some more practice in, like having this be an, oh yeah, we did this before moment. It's not bad. So let's work backwards here. I've got x equals 4 plus 5i, or x equals 4 minus 5i. So here I want to subtract 4 minus 5i from both sides. Here I want to subtract 4 and add 5i. Yeah, this might be refrigerator shit. Probably even better if we had like a radical in there, right? Like if this is 4 plus or minus 5i root 3. Wouldn't that be good stuff?
Don't get any ideas.
I got feeling inspired. What do you mean no? Yes. The answer is almost always yes. All right, this means we can put them together. This has got to be done slowly, right? We're multiplying two trinomials together. It's got to be done in parts. So, like, first off, I'll distribute the x to everything. Boom, boom, boom. I have x squared minus 4x plus 5ix. Then I will do the -4. -4 times x is -4x. -4 times -4 is 16. I don't have a constant number yet. And -4 times 5i is -20i. I don't have just an imaginary number yet. Finally, I'll do this one. -5i times x is -5ix. -5i times -4 is plus 20i. And -5i times 5i is -25i squared. Now I did these rather than doing them side by side. I did them, stacked them so that we could add vertically. I have x squared minus 8x. These cancel, right? I've got a plus 16. The i's cancel, those go away. And -25i squared, I squared is -1. So -25 times -1 is 25. And we still have our equal 0. So like if I were to go regularly, I would add those together, right? Is this one solvable though? Do we know how to solve this? Forty-one's a prime number. So like we got factoring shit. Well, clearly we know it factors. But you're never gonna come up with -4 minus 5i, -4 plus 5i as your factors. No matter how many guessing and checking you fucking try, you're never gonna get that. So how do we get there? Like, how do we even get to what we started with? We started with x minus 4 squared plus 25 equals 0. How do we even get here? That's where we started with. That is called completing the square. How do we get there? Completing the square, that's 10.2. And we will do that right after break.
This is where you do 1/2 b squared, right?
Yep. So I'll hit pause. Let's take a, I don't know, 6 or 7 minute break.